Hello, I've been playing with the routine now that calculate the emission flux, and as a way to make it more portable and and do one thing together without going to start with one routine and then another one that does the line flux. I did a modification in in a routine called EQW Pro that you all have um, in your process subdirectory, and in the process subdirectory. The routine is listed in there, are mostly developed in Berkeley, and what I did is just a small, simple change it. In fact, I changed the name to line flux, and what it does is the same thing as EQW, except it also brings in information about um, the template, because I want to plot the template together with the emission lines. So basically, the routine helium 15876 that you're seeing here is routine call in Titori template, and also cut in 30 angstroms window, right? And then do a normalization manually. So now we are kind of being careful in doing normalization, clicking on 4 points and doing a polynomial fit of third order, okay? And that is going to be the continuum. And then divide the star by continuum. Do the same with the template. Divide template by the template continuum. And then it goes to restoring the veiling calculated automatically with the routine veiling.pro, and does an average between that spectral region 5,600, 5,900, in fact 300 angstroms window, because there is a lot of scattered, and then do the deveiling on the T20, so it doesn't veil template, right? So now that you have the veiling, you deveil the T20, and then allows, I put a loop here that allows you to fudge the veiling in case the automatic one is not good. And basically what you do, you look at these two lines over here and see if they are matching well, okay? And then once we are happy, it goes to the routine EQW and then calculate the flux, and then saves that information, the profile of Titori, the veiling value that was saved, that was fudged, maybe, and the total flux of the line, and the Julian date. The Julian date is important because we want to later on see if there is some variability on flux emission with excess continuum. Okay. So this is the routine I'm sending to you. In fact, I'm sending both of them. This one, helium one, and the line flux, which is a variation of EQW, and that goes into your it's all concatenated, both of them. Now, what I would like to show first is, I don't know if you notice, there is the red wing kind of falls down, and I thought there was a problem with data reduction. And then what I did, just to make sure I know what's going on, I called the template, right? And the T20 record 1 right here. I call them, and outside I plot them in the range 5860 5890, which is, this is the template. And then you have this wing falling down, which I thought was some problem with data reduction. But then I say, wait a minute. If I go to 6,000 angstroms, This is the wing falling down. It's not a problem with the reduction, but it's a big absorption line. So these two lines are sodium lines. So you know that in the past San Jose was kind of a yellowish because of the glow coming out of the street lights. That yellow is because of this sodium line here. Except that in the template it goes in absorption. In the T-Tori both of them go in emission. See these two peaks over here? That's the sodium line in emission. Right? So this the helium line, which is right here, doesn't appear in the template because helium needs a lot of excitation, and the template is cool and doesn't have magnetism, doesn't have disk, doesn't have nothing. But if you look at T-Tori, then you can see the helium line here and this doublet, sodium doublet in emission. Okay, so technically, if you mark a continuum, it has to be something that goes up here. So this is the real continuum for this line. So what we were doing, I was doing before, going down here is not correct. So the continuum is something that should go straight over here, and this curve is the wings of sodium lines, which is less pronunciated in the T-Tori because the center line goes in emission in T-Tori, so it raises the wing a little bit because of that. Okay. So let me run this code and see how it goes and what you should do. So you call, and then as you read over here, click 4 points, identify as continuum, mark left to right, and then you go 1 point, and then you have mark over there. The second, the third. Now is a complicated issue because see, this is the wing of sodium line, so the continuum should be somewhere here, and then you can see the peak going in emission right here, right? And then once you're done, you click any. If you click anywhere, you're gonna reduce. You're gonna do the continuum again. But if you are happy with it, click right of the window. So that's what I'm gonna do. I'm gonna click right of the window, and then I'm happy, and then I'm gonna go do the template 1, 2, 3. See, I'm gonna put the continuum kind of right here, and I'll say that I'm happy. So now has the human factor. I'm looking at these lines over here, and the spectra has been deveiled 0.6, and that is done automatically. So if I can fudge, see that? Click right of the window to increase this much in veiling. So if I click right of the window, the veiling increases. So I deveiling more, and as I deveil more, see not only the absorption lines grow, but also the emission grows because you're deveiling more. But if you're deveiling less, you click on the bottom of the window. So I put a human factor just to allow some control. And if this is done, then let's say we are happy with that, right? Then the final value is 0.75 on that region. So the automatic veiling routine came up with a veiling that was, let me see if I have it here. There you go, 0.6, right? And the final value we got happy with, or at least I did, 0.75. So 0.15 within the error bar. So when you see this scattering, the veiling, so you have an error bar that we have to to claim for. So I would say, okay, we are happy, you know, 0.7, 0.75 maybe. And then we save. So click over here in the left, click left of the window to save veiling, and then you go to the process of calculating the flex. So this window here was open from within the line flex, from within the routine line flex, this one over here. And as you can see, the matching is not perfect. You know, I could deveil more, maybe. Also note in this green line is where the line center should be. So what information can we derive here, just visually inspecting? That the line is not symmetric. It should be symmetrical, but it's not. And the fact that you have a large red wing, this indicate some inflow property of the gas that later we might need to address. Also, you can see two different components. One is broad and the other is narrow. So there is a narrow component that is asymmetric and a broad component that is also asymmetric. Both of them seems to indicate an extended red wing. And then what I do, I mark the flex. Click here and click there. That's it. So this line flex, what it does, takes the emission flux or points, right, and subtract from the continuum. So you are pretty much measuring the intensity of the photons above the continuum. So it's what comes out of the external region. And then this routine understand that when you are happy, you click down here on the bottom, and then it saves the flux is 4.63, and that's what I would like probably Shaunak or Phillips, if you guys are available, to do in all the 9.2 records, and I would do the same, so then we could compare our results this coming week. Sometime this coming week, I would like to talk to all of you. Okay. So let me see what else. So meanwhile, I will redo all the veilings because the routine veiling seems to be now doing a better automatic measurement. And what I did, the determination of where the continuum should pass seems to be an important issue. And so I'm using the measurements over 20 angstroms window, and I'm kind of eliminating as much as possible some emission lines and some water lines, which are telluric waters or telluric lines in our atmosphere. So I'm taking them out of the process. So in a better thing we could do is probably go in one inspection throughout the entire spectra, eliminate all the windows that have bad pixels or emissions, but this is going to take forever and we don't have the time. So basically what I'm going to do now is to run veiling for all my records, and you guys should try to do the same so you have the latest measurement of veiling possible. So I'm gonna do this for any any 0, 10, 9, no 1, 10, 92, do begin, and then calculate veiling for the record N, beginning 4000 angstroms, smooth 6 pixels, rotate the star 4.5, and do a 20 angstroms window at the time in the automatic mode, no plotting. And so I have my veilings all recalculated, and the final result seems to be slightly better than what I had before. And that's it. And I will save these two routines line flex as it is. That's the latest one. I'm saving this one too. And I'm gonna send this to you guys.